Hi everyone, myself Ch.V.V.S.S.R.Krishna Murthy. I will be handling your mechanics of solids with a code of 20ME303. In this session, I want to discuss what is the preamble of this course, syllabus, outcomes, mapping of C.V.S.S.R. with P.V.S.S.R., elasticity and plasticity definitions, and stress strain definitions, and types of stresses and strains. So first we shall go with preamble. Preamble is nothing but what we'll be learning in this subject. So the course starts with introduction of elasticity and application of linear elasticity. And later we'll be analyzing the stresses and strains developed in various practical problems. After that we'll be solving the structural mechanics of non-circular members, non-symmetric bending of beams and beams of elastic foundations. So these are your 5 units, and the first unit is simple stresses and strains, and second unit is shear force and bending moment, and your third unit is flexural and shear stresses. Fourth unit is deflection of beams and torsion, and last unit is thin cylinders and thick cylinders and columns. So preferable textbooks are R.K. Bansal, Strength of Materials by 15th edition, and Gray and Finchko are the most important textbook for your mechanics of solids, and I will be following the reference books Bhavapati and S.R. I will be preparing the course material with the help of these 4 textbooks only. And for your web references, you can use the NPTEL course with the following code. So there are 5 outcomes. Outcome of course is nothing but what you will be analyzing after the completion of this subject. We will be analyzing the out concept of stresses and strains of various cross-sectional bodies, and also you will be able to solve the shear force and bending moment problems for various supports and loads, and identify the shear stress due to application of twisting moment, solve the slope and deflection of various beams and support arrangements, interrupt the stress analysis in thin and thick cylinder stress. So these are the 5 outcomes, and now I'll map these outcomes with our POs. The POs are given by the NBA National Board of Accreditation. Out of 12 POs, we have mapped our course with 3 POs. One is PO2, PO3, and PO12. PO2 is problem analysis, and PO3 is design and development of solutions, and PO12 is lifelong learning. So the first sentence of the outcome is outline the concepts of stresses and strains of various cross-sectional bodies. So as we are dealing with the problems of solving stresses and strains, so I mapped with PO2, and you will be able to develop the solutions for and designing. So it will be 3. And PSO1 is program specific outcomes. This is a statement, and the degree of knowledge will be in remembering and understanding. So L1, L2, L3 are nothing but RBT revised rules section. So this is the mapping of COs and POs. So first we shall start with introduction of mechanics of solids. The deformable solids is more concerned with internal forces and associated changes with the geometry of components involved. The mechanics of solids basically involved with internal forces and associated changes in the body. So whenever you apply load on a body, there will be some deformation. So in this mechanics of solids, we will be studying how the forces are acting on the body and how it gets deformed. And in further, it will be stiffnesses and also be acceptable. So the mechanics of solids is the central of whole activity of our engineering design. In this analysis, we will be determining stresses, strains, deflection produced by loads, and theoretical analysis and experimental results have equal roles in the field. So the entire mechanics of solids can be compressed of 4 steps: applied load, stress, strain, and displacement. Whenever you apply load, there will be some stress. Due to this stress, there will be some strain, and the strain will be causing displacement. So these applied load and stress will under equilibrium conditions, and the stress strain relations can be found using constitutive equations, and the strain and displacement can be found with the help of kinematic equations, which will be going through further. Now going to our first unit, first topic, what is elasticity and plasticity? So whenever you apply a load, there will be some deformation, and even if after removal of load it regains its original position, then it is said to be elasticity. So if you take a rubber band and you stretch it, so which means you are applying a load, it is stretching. Once you remove the load, which means it is again it's regaining its original position. So the rubber band is the best example for elastic nature. And if the body does not get its regained original position once even after the removal of load, then it is said to be plasticity. So now hope all clear with what I mean by elasticity and plasticity. So next, what do you mean by stress? Stress is the ratio of applied force under a cross-section area, and shortly defined as force per unit area. So these stresses mainly consist of direct or normal stresses, shear stress. Types of stresses are considered as direct or simple stress, indirect stress, combined stress. Direct or simple again is classified as shear and normal, and again normal stress is subdivided as tensile stress, compressive stress. Indirect stress are classified as torsional and bending stresses. So now first we shall go with individually. Direct stress is nothing but stress normal to the plane. If the load is acting normal to the plane, then it is called as normal stress or direct stress. That is given as stress is indicated with sigma, that is equal to Fn by area. Okay. Shear stress is parallel to the plane, then it is called as shear stress, and P is equal to tau. It is indicated as tau, that is equal to Fp by A. So now what do you mean by normal stresses is subclasses tensile and compressive? So whenever you are whenever a body, just a second, whenever two equal and opposite forces are acting on a body, okay, then the applied load is in two equal and opposite directions. So if you take this is solid and you are, suppose this ball is a solid, and if you want to stretch two sides equally, okay, then what will happen? The body will be elaborated. Okay, so that is called as tensile stress. Whereas compression means two equal and opposite forces are in the same direction. So if I press like this, then it is called as compressive. Okay, torsional means twisting. If you see here, compression, both the forces are in the same direction. And the tension, it is opposite direction. Shear is perpendicular. So torsion is twisting. So hope everyone is clear with different types of stresses. Next, strain is nothing but deformation of solid due to stress. Whenever you apply load, then the body will be gets deformed. So if the change in length to the original length is said to be strain. That is E is equal to small e, that is equal to change in length delta L by original length LO. And it can also written as strain is equal to stress by Young's modulus. So in the few other topics, we will discuss what they mean by Young's modulus. Okay. Strains are also subdivided as normal strain and shear strain. Normal strains are nothing but longitudinal, lateral, volumetric, and the lateral strain means tensile strain and compressive strain. So now what do you mean by longitudinal? If it is considering only the length of the change in length, then it is called as longitudinal. If you are considering other than length, okay, which means a width or a thickness, so the change in thickness to the original thickness is nothing but lateral strain. Okay, volumetric means change in volume to the original volume. If I will be considering both length, width, thickness, everything. Okay, again these three are subclassified as tensile compressor. Based upon the applied stresses, it will be classified. So some short answers questions which are asked in your university examinations. Stress define strain, classified stresses, strains, elasticity definition, plasticity definition. Hope everyone can write these answers. Thank you.